Right. Okay, so a few people are saying that they're struggling with exercise 11E, which is difficult. Therefore, I'm just going to go through question 1 with you. I'll try and break it down as much as possible, and it would be really appreciated if you could email me in the event that it still doesn't make sense. Little fact for you, this is the 3rd time that I've been recording this video because I keep running out of space. I've just gone through. I know a lot of people are bored, but some people have sent me the same video 6 times. I've just found out. Different groups, obviously, not the same person sending it. That would be crazy. But yeah, sorry if I sound slightly abrupt. It's because I've done this a couple of times now. Okay, right. A particle moves on the x-axis with constant acceleration a. The particle has initial velocity of 0 and initial displacement of x. Whenever I see initial, it means that when these things are happening, I know that t equals 0, because that's what initial means at the beginning. After time t seconds, the particle has velocity v and displacement s. Okay, prove that s equals a half at squared plus x. Well, if I think about it, what am I trying to do? I'm trying to express displacement s in terms of a and t, and in this case x. I'm thinking to myself, how do I get between these things? Well, if I have acceleration and I integrate it with respect to time, it will give me the velocity. If I integrate the velocity with respect to time, it will give me the displacement. Right. If I have, just so we have this all in one diagram, because I get a bit confused with the integration sometimes, but it makes far more sense if I go the other way. Yeah. So if I have the displacement, if I differentiate the displacement with respect to time, that's going to give me the velocity. And that makes sense because the velocity is the change in displacement over the change in time. Just as velocity is acceleration is the change in velocity over the change in time. Right. So if I have acceleration, integrate to get to velocity. If I have velocity, integrate it to get to displacement. Ultimately, I know that my expression for displacement has a in it, so I'm going to have to integrate a once and then integrate v in order to get to s. Where do I begin? The particle moves on the x-axis with constant acceleration a. It's just telling us it's the x-axis, so I don't need to worry about it going up or down or anything like an incline. So if I integrate with respect to time, that's going to give me the velocity. Yeah? So if I integrate a, that's going to mean that that's essentially, if I want to think about it, at to the power of 0, because anything to the power of 0 is 1. So if I increase the indice by 1, divide it by the new indice, that's going to give me at over 1, which will just be the same thing, plus, whenever I integrate, I have a constant of integration, is equal to my velocity. I'm told in the question that the particle has an initial velocity of 0, i.e., v equals 0, and because it's initial when t equals 0. They've provided us with that information in order to work out what the constant of integration c is. So if I have a times 0 plus c equals the velocity, which they tell us is 0. That equals 0 equals 0. I've just worked out c equals 0. Rewrite my equation. V equals at plus c. V equals at plus c I've just worked out to be 0. This is my equation for the velocity. Right, what do I know now I have the velocity? Well, if I integrate the velocity with respect to time, integrate with respect to time is going to give me the displacement, and ultimately I'm seeking to get to the displacement. So v is equal to at. I know I want it in terms of a and t because it says it in the final answer anyway. So if I integrate my expression for v, which is at, with respect to time, is going to give me my displacement. So increase my indice by 1, so that's t to the power of 1 already, so increase that by 1, it's going to be at squared divided by 2, divided by the new indice, always adding my new constant of integration is equal to s. Now I look, my initial displacement is x. So that's telling me my initial displacement, or my displacement is x, is s, that's equal to x, and because it's my initial, that's when t equals 0. Substitute that in order to work out what my new constant of integration is. I've got a times 0 squared over 2 plus c is equal to s, which in this case is x. What have I got? A times 0 squared. Oh, that's times 0, isn't it? So all I'm left with really is c equals x. Let's rewrite my expression for s. I have my expression for s here. Sorry. So s equals a half at squared over 2 plus c, which I've just worked out is x. I've done it. I've proven s equals, well, it's the same. It's just the same way as writing s equals a half at squared plus x. Yeah. So here we have our final answer. Let's just talk through our steps. I know that it started with the acceleration and then it gave us these pieces of information here. So when I integrated, I could work out the constant of integration each time. When I put these in, it told me that my constant of integration was 0. So I just got v equals at. Integrate my expression for velocity with respect to time. Blah, blah, blah. Then I input these bits in order to work out what my new constant of integration is. And then I got the expression that I was after, the formula equation that I was after. Yeah. Please email me with any questions that you may have. Thanks a lot. Keep up the hard work.